Okay, I think the audio is working good.
Yep, I tested the mic.
It's good.
Let me try your computer again.
I'm not giving you a disappointed look, I hope you know. My eyes don't say a lot of words.
They just exist.
What are you doing with the math today?
I'm sick. Adjusting.
Yeah, I want to, like, you know,
You want to be seen.
yeah. It's not my fault, I'm sure.
I'll give you your stepping stone. 360.
Yeah.
What is that? Alcohol?
Mm-hmm.
Yeah.
Last Oh.
An actual EE guy.
Wow, you'll finally understand.
Which means he's doing very good.
I'm doing great.
Yeah. Did I do a psychological classes?
Derek,
No.
don't answer all the questions. Tell them you're major.
Robotics, and then robotics.
Yeah, that's cool. So, I was going over this on the line. I'm pretty sure, I had like, a stuff yesterday.
How does this schematic
slide.
look?
I was thinking, what's that? You have to do a great
You want to tell
job.
them what happened with it?
You have to do a
Oh.
great job.
It actually doesn't exist anymore. It's been deleted, so I have to redo it.
Cool.
But it's okay. At least you get to see it.
Let's make sure your Altium works correctly. We'll do a small thing to try to save it before you try to say something big again.
That is true. That's what I do.
You're logged in, right?
Mhm.
That's interesting.
No, I've checked the Altium workspace. There's only like 2 files in there.
It's
The
not
old
saving
schematic
to upload.
and I think one of the PCB designs. Nothing else
What's
in
the
there.
newer one? Wait, the what
Yeah.
again?
No, not the new one. New one's saved locally on Caden's computer.
Yeah.
What
So,
was it?
yeah.
In theory. I haven't found it. I was looking for it.
Wait, alright.
No.
What files?
The harness schematic.
Yeah, these.
Oh.
It's okay. With a physical diagram, it should be easier to redo.
Yeah.
Because you did it twice last night, right?
Just copy it.
Twice.
No, I redid it once.
Oh.
I've just redone the harness twice. It's okay.
Because yesterday I had to just redo it.
Are you guys doing karma like $100 for my pizza or something?
You're gonna get reimbursed later.
Bye now. Are we ready to start?
You're really excited, huh?
No.
We can go ahead and start.
I didn't
Starting?
say that.
Yes.
So is it recording now as well?
It's recording, yeah.
Okay. So, hello everyone. We're going to start our critical design review. So, what we're going to discuss here today is we're going to go over the team overview, the competition overview, the strategy overview, the software, the mechanicals, and the electrical systems. And then additionally, at the end, we're going to have a Q&A if you have any questions regarding that as well. Okay, so first and foremost, what is ISC? So the purpose of ISC is to have hands-on projects in robotics, autonomy, AI, and embedded systems. And what we intend to gain is real-world engineering experience, teamwork, and also leadership. What employers gain is that they gain industry-ready engineers with strong technical skills. And then essentially our goals is to build advanced systems, compete nationally, and prepare members for careers as well. Okay, so let's explain the leadership and the executive board. So my name's Ria. I'm currently the president of ISC. Over here we have Taha, who is our chief engineer. We have Alex over here, who is our Phoenix software lead. Cadence over here, who is our Phoenix electrical lead. Trace unfortunately couldn't come, but he is our Phoenix hardware lead, and also Shivani is also here as our hardware lead. Isabella couldn't come unfortunately either, but she's also our head of public relationships. And then Elijah over here is our tiny cart lead. So, okay, so the project overview, the Autonomous Karting Series competition. So it was founded in 2019. The Autonomous Karting Series is a collegiate autonomous time trial style competition where university teams design, build, and race self-driving go-karts on a closed circuit with no human intervention. This program provides a platform for aspiring engineers to gain valuable industry experience and network opportunities. So this is a little bit about the AKS participants and infos. The competition is May 18th, and then some of our participants include Intelligent Systems Club, UPenn, Autonomous Motorsport Purdue, Robo Jackets, Banana Bots, electric vehicle teams, and Purdue, and more. And also, this is what our racetrack looked like at the Autonomous Karting Series competition, where it will be hosted at Purdue University, like I said, in May 18th. So previously at our last competition last year, or I should say last summer, we received the engineering award. Yay! Yippee! Okay. So Project Phoenix. Tala, you want to take over?
Yeah. I wanted to give a brief overview about some of the milestones that we're looking at. Following the CDR tonight, we want to have our motor test early March. I know this is planned to be over break, so we'll see how much we can get done. I know we're not technically meant to plan over break since we can't really count on people's attendance. Hopefully this won't take too long. We want to have an in-air EMI test following spring break. Of course, because EMI is a huge issue on the kart, and we're hoping to see what kind of effects it has on the kart this year. We want to have our on-ground testing in March, though this schedule mostly depends on the parking lot outside, which we can get from FSAE Combustion or Electric, because they already have it reserved on Saturdays and Sundays. And we want to get some of our final test data in on early April, so we're ready for our competition mid-May. I have attached our Gantt chart for each subsection, which on the handed out copy you guys should be able to view on your own. I do urge you guys to take a look at this and ask questions on it towards the end of the presentation. Alex?
All right. So the overall strategy this year is a pretty big departure from previous systems. The camera will no longer be the primary sensor for navigation. We are moving towards a pre-mapped route using global waypoints for the kart to follow. The waypoints will kind of give us the path. From this path, we'll be able to generate the traditional steering commands and speed commands to follow. Global positioning will be provided by the Kalman filter and GPS. This will be fairly solid and reliable compared to what we've been working with in the past. Cool. All right. So, this is a potential strategy visualization. What is concrete is the spline. From this planner and object tracker is potential side quests for this year. AKS is attempting to move towards multi-kart racing as quickly as possible, which will require a form of obstacle detection. More on that later. All right. So, for those who are unfamiliar with the sensors on the kart, Phoenix runs on top of a Dell PC for our high-level autonomy. All the software is ROS2 Humble. It is implemented on Ubuntu 2204. Most of the stack is in-house. The GPS driver is provided by a third party, including the ROS2 node to interact with it. And localization is provided by the external packages, robot localization. This includes our Kalman filter and NavSat transform node. All right. So I've covered a little bit of this slide, my apologies. But we're kind of moving away from the camera-based reactivity that we had last year for navigating the track. We're still keeping the camera for obstacle avoidance. The primary reason is that we need a ground truth for the kart to follow. At speed, it is difficult to necessarily plan around corners and race super fast, especially compared to just to what the other teams have been doing. We're following with a bit of what they're going. In addition, with obstacles on the road, those being unpredictable obstacles like carts, it might be not as feasible to parse the edges of the track the way we did last year. There might be obstacles in the way blocking it for a significant portion, particularly if we're following a vehicle and that vehicle is hugging the edge. We won't be able to see what it's looking at. So that's the reason we're moving away from the camera system. All right, so a little bit about the sensors we will be using. The current GPS on the vehicle is the VectorNav VN300. This is a tried and true GPS that we have been using for older robots. It is a dual antenna GPS system. It has it is waterproof and weather resistant, which is very good for us as we are required to have waterproofing for the exterior components of the vehicle. It has a 400 hertz IMU to provide updates in between the GPS updates. Those GPS updates occur at approximately 10 hertz. Yeah, cool. It also has compass heading for true north, in addition to providing dynamic heading based on how the vehicle has shifted over time. So, we've covered a bit about why GPS. We'll talk a little bit more about why the waypoint strategy. So there's a couple of ways of navigating with GPS, but they all basically involve the same thing. You have a point you need to traverse to. What we learned from other teams at competition last year is that the more GPS waypoints you have for the cart to follow, particularly over a very short period, is that you tend to get clutter. These points are not necessarily as accurate. So if you have a bunch of points in one space, there will be variance in the line you follow. This will introduce a lot of instability into the vehicle. Now, some attempts to mitigate this, like PID, could be attempted, but what was recommended is to just not have as many waypoints. So we will be trying to do a more minimalistic waypoint approach. Cool. So our waypoints will, as of now, they will contain GPS coordinates. They will have other control parameters, more so to do with the spline. My apologies, I forgot to update the speed. Speed was talked about as a way of controlling. Whether or not that's practical, it's something to consider. I do not believe it is not included in the current design though. My apologies. Oops, sorry. Yeah. Cool. And that's just the final point I have is rehashing the pre-planned system. So the idea is that the ground truth that we will have will be a perfect path, one that you can follow much better. Results from competition last year showed that if you do have a really good map, you can beat the track record. UC San Diego was able to beat the human record with the autonomous vehicle just by having, perfect. Cool. So a little bit where we are going to be differing here is that we will be using just the antenna, the onboard GPS. RTK has been a favorite of systems at competition. There's been an RTK base station there. There was one last year. I believe there was one there in 23, although I'm not sure about that. Yeah. However, we don't need it. The VectorNav I mentioned is a dual antenna system that gives us a much higher accuracy, approximately centimeter level without an RTK station, which is sufficient for our purposes. Gosh, I forgot to update that bullet point. Yeah. So, the advantage of not using RTK is it is a lot less setup to test the vehicle. It does take a bit longer to connect. You can mitigate this by leaving the cart powered on, but in a stopped state with the wireless e-stop. This will give power to the computer and allow the GPS to connect to the antennas while we're still prepping for other things. All these updates are still going back into the Kalman filter. We will be also using Navsat Transform. This is another package provided by Robot Localization. This will handle the transformations from GPS to the robot space. Cool. All right, so we'll talk a little bit more about the waypoint strategy we're having, some advantages. By using waypoints, we can navigate a ground path regardless of what the terrain looks like. This was a huge limitation for us last year, especially with regards to testing, is that we needed a track that looked like Purdue. And what we attempted to use was the sidewalks. There were some significant issues with the sidewalks, primarily being that U of M Dearborn does not use the correct salt. This burned the grass edges and gave us very poor lines to follow on the edge here. With GPS waypoints, we can test wherever the ground is flat and the cart can move. Let this be the parking lot, a track set up by other competition teams like Formula Electric or Formula Combustion, which gives us a much, much more flexible testing strategy. It also means that we will have to be more active at competition because we will need to build this map day of. So the testing strategy is going to look a little different this year, whereas in past we just verified the capabilities of the cart. This year we're not just need to verify what we've done, but we also need to practice putting together and using it. Otherwise, we're going to get to there and we're going to spend a lot of time filming over ourselves. This will still happen. Hopefully it will just be happening without the pressure and stress of competition, but just in our parking lot on our own terms. There are some disadvantages to this. I already mentioned that it adds time, but this means if you want to go to a new circuit, you have to map it out. So you're going to need to spend time gathering data, collecting the data, and processing it for you to follow. It's going to be less reactive to changes in the road. Although technically this really isn't necessarily a disadvantage because the roads don't move. Something to keep in mind is that if you get it wrong, it won't be able to react. So you'll need to get it right the first time. Other disadvantages is that waypoints are much, much more boring compared to camera systems. They're still cool, just not as cool. So we'll talk a little bit about our waypoint generation. So we will be having waypoint classes in our planner. These will be containing the GPS waypoints. I have a visualization of some of our in-house testing we've done before simulation. You can see that the blue line there is the actual path of the road, whereas the green waypoints represent a path through it. That sort of path isn't necessarily what we will be working with it, or what we will have at AKS, so I don't foresee the poor fitting being an issue. The waypoints themselves will be a circularly linked list. The idea is that compared to using something like an array where you have a start, just define start and end, the track is a continuous circuit. There's no need to necessarily use those sort of strategies. We'll have to choose them through from this list, so there's a few ways of doing that. You can pass off as a parameter when you launch the vehicle to tell it which waypoint you want it to start with. You can have we're working on a potential system to decipher where it is closest to the spline and then go with that on startup. There's a few ways that we have not yet settled on. Cool. Oh, an intersection of the waypoints. Two strategies. One is just have each waypoint has a radius. Once you've crossed through that radius, you're now moving on to the next one. This doesn't mean it won't be discarded in the spline, but it does mean that it will no longer be the primary point the planner will be focusing on. The other one is through what they call a gate. So this was borrowed from video game design, but the fundamental idea is that you have each waypoint has a heading, a direct heading. If you have a line orthogonal to that heading, you have a sort of barrier that the cart can cross. Once you've crossed that barrier, you will know pretty confidently if you've gone over the waypoint. Advantages is that this allows you to go through with a little bit of air on the track, so you don't have to go directly over the waypoint. For example, you set your radius too small. Disadvantages, you'll have to have magnetic heading as part of your planning algorithm, so you won't just be working with raw points. So the splines, we have, as of now, in the previous slide, you see that you have the green point here, and then you have little dots that connect in between it. The green points are representing GPS waypoints, and the dots represent the spline that we build to extrapolate between them. That's linear. Some other suggestions were potentially circle. There's a few ways to generate a circle. The demonstration here is a 3-point method for creating a circle. And the other method is that if one of those lines has a tangent vector, you can get rid of one of the points on the circle, and you can create a 2-point circle system. Has the same disadvantages before with the hero gate, is that does require you to know the heading. All right. I will give the floor to Mark to talk a little bit about the communication updates to the vehicle.
All right, so firstly, talking about the IP connectivity that the cart will have, this was something that we were told about by AKS earlier in the year. What they want is IP communication from their base station at the track to the carts. So we're going to be using the hardware that they recommended, which is the Ubiquity Bullet AC system. It's just a line of access points that are designed to have a special kind of point-to-point connectivity. And it just runs off of standard 2.4 and 5 gigahertz bands that you would see for Wi-Fi. And it has 21 dBm of transmission power. So not only is it required, or at least highly recommended by AKS to have this so that they can communicate from the cart, communicate to the cart from their base station, but we think it'll be really useful for in-house testing and development. We're using new systems. We're kind of working from the ground up with a lot of things, and software-wise, we're going to have to do a lot of tweaking and a lot of monitoring. So what we can do is we can take the cart out wherever we choose to take it, and we could have a live view, either RDP, remote desktop, or SSH, some sort of protocol to communicate with the onboard computer. And that way we could monitor actively and live, and we could tweak and update things much more efficiently during the testing phase. That is where I really believe that we're going to get the most use out of this. Second part would be antenna choice. So this is sort of a up in the air thing. Right now we're ordering antennas. They should be arriving soon. That will be 9 dBi, both RX and TX gain, omnidirectional. So that should give us hopefully enough to communicate with the cart over whatever distances we will be using at the at competition. But with communications like this, it's very complex. You can all of a sudden run into a lot of errors. So we have some very, I don't want to say crude, but very basic models for what we might expect for losses and link budget with using these antennas. You can see right here. So 200 meters, which is honestly the most we really expect to be communicating with the cart over. We're still getting some decent link budget. But once again, a lot of this is based off of some assumptions, and a lot of it is going to have to be reinforced with real-world testing once we get those antennas. Worst comes to worst, if we need to, we can get for the TX, we can get a directional antenna. So that will be, obviously, it'll shorten the sort of angle that we can transmit at, but conversely, you will get higher gain, and you'll have better communications with the cart. Once again, this is going to have to be a lot of testing, which will hopefully happen quite soon. I don't know exactly when we are set to have those antennas arrive, but as soon as they do, we can begin testing. Right. RC devices, I'll hand that over.
So for the RC devices, we'll be using the FlySky i6, which was one of the drone controls I had on hand, which has pretty good distance. We will access through PWM through ROS2 serial library. So in order to read from it, we're essentially piping it from an Arduino onto the serial bus on the computer through USB, and we're going to be reading to the ROS2 serial library rather than the C++ serial library. And yeah, here's just a small snippet of the code that is going to go on the microcontroller on the Teensy. Right now it's configured for Arduino, but just a few port changes and we should be able to run it for a Teensy. Side quests.
Alright, I'm going to talk about our first side quest, which is multi-cart obstacle avoidance. The idea this year is that we're just going to kind of throw all the carts on the track and pray for the best. That is unfortunately a direct quote. But I don't foresee necessarily huge conflicts. We were talking quite a bit about the feasibility of a crash. It was a principal concern of the ISC team. However, we were fairly confidently assured by our friends at UC San Diego. where was Mark? Mark was San Diego, right? Yeah. Our friends at San Diego were saying that they have, in fact, done some accidental crash testing of the go-karts, and they can assure us that they will survive. In fact, the components on their carts were very sturdy, and they did not have to replace anything. So their theory is that at 30 miles an hour tops, we should be good. They were, pretty insistent that their IndyCar that had once crashed, they said that the components, or I don't think it was theirs, they said one of the Indy cars that had crashed, its components had actually managed to survive. The car obviously did not. 150 miles an hour is never survivable for any vehicle. So, it is an extra expedition event that, we will get nothing but no awards from, but still a very cool thing to participate in. Development will happen after we have mostly wrapped up waypoints. I do not want to risk the potential delay or incompletion of the primary navigation stack. So there's a few approaches to it. One is to use the camera plus a depth model in order to estimate the position of a cart. In effect, you can just get its known location and you can avoid it. There's talks for next year to have the race control module broadcast the cart's location. And that way, everybody knows where everybody is, even if you can't see them, and you can just add that to your obstacle avoidance algorithms. At the moment, we're not planning to dodge anything behind us. All obstacle avoidance sensors will be in front of us. We will hope and pray the people behind us also have done the same. It will be hopefully very cool. I'm actually looking forward to doing this. We also could use the LiDAR. The issue being is that it's 2D. We will chat with them Monday about the feasibility of potentially cardboard or something just to raise the silhouette of the vehicles in front of us. The mounting point of the old LiDAR, is about a foot off the ground. It's pretty high. The Kennesaw's, and I haven't seen San Diego's redesigned cart, but Kennesaw's cart would be entirely below that. It does not exceed very high up above the bumper. So you relying on it to reliably detect a vehicle in front of it, which it would do very well, will require a bit of cooperation with the other teams. But we'll chat and we'll see how it works. If the LiDAR can't be used for a more reliable depth method, we'll have to switch back to using some sort of depth model from whether that's the one that comes on the cameras, our OAKDs, or if this depth model comes from like something open source potentially. There's a lot of options out there. The primary method for avoidance would be mostly speed control. Although you can autonomously, you just shift your path away around the vehicle. I don't see it being feasible, at least not without, set rules for the other cart. If there is we won't be able to see behind us. So by the time we get side by side, I don't know how the planner would know where it is and be able to dodge it. So unless we're able to integrate a 360 camera, which will most certainly not be happening on our limited time budget, we'll have to just settle with, not hitting anybody, which is still a very cool achievement. Definitely a first, I believe, for this club. All right. And then our other cool side quests.
Hello everyone, I'll be continuing the presentation with our other side quest, that is LPV-MPC, which stands for Linear Parameter Varying Model Predictive Control. So earlier what we were using was a hybrid pure pursuit, which uses a pure pursuit algorithm tuned with a PID controller. So basically what I'll be talking about in these slides is why are we using it, what is the similarity between the hybrid pure pursuit that we had earlier, and what does the actual control looks like. So beginning with the question why. So the improvement over the pure pursuit we have with the model predictive control, that to linear parameter varying, is about the steering law. So as pure pursuit use the vehicle's kinematics, it doesn't use the vehicle dynamics, which makes it less tracking friendly. and more prone to errors. Whereas including the vehicle dynamics and using the tire forces would be a better alternative to the same problem. So the problem why we are using the model predictive control is because in pure pursuit we have to use the constraints hard-coded, but for model predictive control it will solve the constraints as a part of a optimization problem. The key aspects of our application will be using the same planner, or the motion planner will be the same, and we'll be just improving the tracking capability of our Phoenix. So the similarities is the speed profile, which will be the same, as we are using the same centripetal acceleration formula for the curvature that the path message will be sending the control system. The ODOM will be the state estimate, which Alex talked about, as a Kalman filter will be the state estimator. And the output will be the same as pure pursuit, which was the steering of the vehicle and the acceleration. So this is how the control would look like. So we have a path planner, which will feed into the control. The path planner will feed into the control, and the control will find the actual velocity that it has to track over the trajectory. And then the controller will be the model predictive control, which will be sending the steering and acceleration to the plant. Here the plant for us will be the cart itself. And we have the Vx, Vy, which is the body frame velocity that is in the direction of the driver, towards the front of the driver and the left side of the driver. Omega will be the yaw of the vehicle while steering. Theta will be the heading angle with which will be calculated from the GPS and IMU sensor fusion. X and Y will be the global coordinates of where our cart actually is. And we'll be using an OSQP solver, which is again open sourced. That will be solving the constraint as well. And in this model predictive control, we'll be using error dynamics. So what we are going to do is augment the state matrix. So what I mean by that is the steering and the acceleration of the previous control signal will be acting as an input to the control itself. Now, Phoenix Mechanical System will be continuing the presentation.
So, hey guys, now that software has done their portion, it's up to mechanical to kind of bring that to life in a physical sense. So, here we go. So this is the top cart, as you guys can see, and you probably have the schematics going around there. But we use the Mott Energy motor, that's a brushed motor and DC motor. And then we have our batteries currently that are 12 volt. We need 4 of them, and they're on the side of the cart. And then we have the ESC, which is the Robotech, and then we have the powertrain, which is slightly modified, only the sprocket. I learned this from the last mechanical lead. And then we have the hydraulic brakes, which I'll come to very soon. And then the total weight of the cart is 404 pounds, which is not light. So motor and steering. So this is kind of like the cause of some issues for us, but this is what we have right now. It's a brushed DC motor, and it's 28 pounds, 5,000 RPM, but it also creates a lot of back EMF, which we kind of tried fixing. I will come to that in the next slide, but currently this is what we're using. We have the motor controller, which is doing a much better job. We chose this one because it supports both brushless and brushed DC motors. and we kind of tried switching to brushless DC motors, but it was an issue because we had to find something that was compatible with this actuator, this motor controller, and that was something we're still working on. But this is also really great for software because it's easy to debug. Whatever this runs on is easy to debug, so they really like this one. And then there's steering. This is great, used for outdoors. We've been using this for a little bit. It's the Technique, and it has a gearbox ratio of 30:1, which is a huge gearbox ratio, but we need that because we need to hit our torque, and this does a good job in that. So brakes. Tala's witty quip here. Everyone just take a second to applaud him for that. But so what do we have right now? We have the e-brake, that's a band brake, and we have the hydraulic brake actuator. Both of these have created issues. The e-brake, we need to reset it manually, which is a problem every single time we use it. And then the hydraulic brakes, we kind of have the issue of if we tune it, it might leak fluids or it might explode, and we don't want that exploding on us. So that's a couple of things. And this is more about the brake actuator. Like I said, there's no way to really measure the pressure for this. So we don't know how much stopping force we need, and then we're only able to fully engage or disengage, and there's not able to stop it just like that. And then this is the one on the cart, just a picture of it on the cart. And then this is the e-brakes that we have. Like I said, again, issue is we need to reset this manually. We kind of want to go past this problem. And this is the solution we have for that. We want to switch to electromechanical brakes, which means that our actuator is going to be fully electrical and our calipers are going to be fully mechanical. And therefore we don't have to deal with pesky hydraulic fluids, exploding on us. And yeah, this is something we're working on. The calipers here do provide enough force for us, and I believe this works at 1000 psi, and the last one worked at 800 psi. So in theory, this is good. We will hopefully have this by comp. GPS mounts. So this again is something new we're implementing into the cart. But this is the mount that we've designed. We want to make this with 6061 T6 aluminum square tubes, and it's going to be placed in the middle of the vehicle, and with some testing, we have the distance between the two antennas to be 1 meter. I don't know how many of you are mechanical here, but aluminum welding is not easy in general. So it might not be possible in Measle specifically, which is the manufacturing lab we have here. So we decided that we'll just use L brackets and screws and call it a day. The only problem is we have vibrations that might affect this frame because it's long and slender. But hopefully the cart doesn't run so fast that that's going to be a huge issue. I don't see it being a huge issue, especially because we have two antennas as well. But again, we test and we retest and figure out a solution. This is just a drawing of this in more detail, nothing fancy. And then we have the cameras and sensors. This is one of the only things that we're not changing in this card right now. It's good as it is, and it's going to be extra useful in navigation, location, and all of that. Okay, So one big thing we've done this semester is, or this like past year, is making everything IP65 rated, because they came up with specifications that they want it to be IP65. And you can ask me, what is IP65? That's literally what I asked myself. So this is exactly what it is. You have to protect it from dust from everywhere and like water from everywhere. So it has to be able to run in like all the conditions that they say that you can run it in. So like moisture, water jets, all of that. And here's everything on the cart and whether it's IP rated. And another reason we love the steering motor, for example, is that it's meant for outdoor use. We don't have to do anything with it. The batteries, which will come up in electrical, I believe, they're also fully rated. But the drive motor is something we're working on, and everything else is not really IP rated. The camera is also IP65 rated. So this is the main housing that you will see in the Phoenix right now. And as you can see, it's sort of messy. You don't really understand what's going on here. But everything I've circled here in yellow is the base. It's the contactor, the fuse, the motor controller, ground wires. And the top part is in purple, and that's all the PCBs that we have on cart. We kind of want to put everything together and make it look neat, as well as protect it from water. And this is what we've come up with as the design for that. So here you can see the base part here. Okay, yeah, there you go, the neon cursor. This part here is going to have everything that I said was part of the base, and then this part here is specifically designed for the PCBs to like just slot in there and they won't move after that. And then we have the little ISC logo that I had to draw out by hand. I had to draw this out by hand on my design CAD software, but yeah, there we go. And all of these holes, as you can see, is like for wiring and for venting and all of that, which I'll come to in a bit. And then we have the encoder casing. So we know the encoder is super important. Main reason why we need a casing for this is because this mount, as you can see here, is not sturdy. It can break any second, any time. We really want to make something better. And also IP65 rating is important. And then the inverter housing, nothing fancy, just a box for a box. So we have the current PC mount. This is also another big project. This is something that I built 2 semesters ago with the rest of the team. 2 semesters ago, and I was super proud of this, but we're getting rid of it because firstly, it's heavy and it's also not enough cooling. You can see these fans are like tiny, they're minuscule. Not enough cooling for the PC that we have, and it's fully open, not going to be IP65 rated. So we're scrapping this. And now we have 2 designs that the mechanical team has come up with. This is the first design. We're gonna put the PC in here, and you can see these huge holes here, and they're going to be fans. We're gonna put a filter over the fans to prevent moisture, but these huge, like 120 millimeter fans, they're not this big, but this is going to be enough to cool it. And then it has a charger it has a charger holder as well. So it's just one whole unit that you can take around. And then this is the other design. It looks really cool. It's more robust. And again, these fans need filters, and they have roofs on this that are sloped, so water can just run off of it. Okay. We're almost at the end. So these are the final things we need to like seal it up completely and, you know, make it actually like sprinkle proof. The first thing is vents. We have these 3 different sizes of vents based off of our design. We have grommets. As you saw, there were a lot of wiring holes. We want to keep those holes minimal. So once we have the wires there, we'll have grommets there as well to prevent any more water. And then we have this sealant, which is silicone rubber, which will go around like the lids and all of that stuff. Okay, and this is just a list of all the housings that we've designed so far and all the vents on it and grommets on it and all of that, which is not very interesting. But that's it. I will give it over to Cadence.
Hi everyone, I'm Cadence. I'm going to talk about Phoenix Electrical. So for this year, our objective was to continue with modularity in our harness and readability, but also we've been working on PCB redesign, and we are swapping our batteries from lead acid to lithium iron phosphate batteries. And then also we're incorporating GPS and RC control into our navigating system. Currently, our wire harness, since we've been implementing some of the modularity from last year, we're going to continue with our battery disconnects. After speaking with a few different people about it, we kind of have the best solution for a quick disconnect already. So we're going to continue with that. And the problem that we faced last year with having to resize it and things when we swap batteries won't be a problem, since we'll be using the same batteries with the same size terminals. So there won't be an effect of different sizing of the hole when you're trying to place the disconnects on. Also, we'll be continuing with labeling and color coordination for our wires to make it simplistic and easy to read. And then we'll also implement onto the harness where we will have labeling on all the connectors, basically a numbering scheme for every connector that will coordinate so we know what's happening. If you're not an electrical member, you know what's happening as well. This is our power distribution chart. Basically what it is showing is that we have our 2 batteries. They're both 24 volts each. They are going into our physical e-stop, which disconnects the cart or all power from the cart when pressed. Then that is going to our right here, our inverter. That will go to our steering motor, our drive motor, and our converter. All those will then split to, our converter will split to our, you can see on here, our converter will split to our encoder and then also our steering motor. And then we have our wireless e-stop, which will then cut power to the steering motor, drive motor, and our electromagnetic brake when pressed. And then from there, our motor controller connects to our motor, our drive motor. And then we also have on here for our inverter that is going to our router, computer, and then our computer connects to all of our PCBs and the GPS and RF control. Here is a picture of our 48 volt schematic, which most of you have on the table. You can see it's in Altium design. That's really the biggest change. I'm sorry you guys don't have any. I didn't bring them over there. But basically on here, this is showing our whole cart, and on the main things to look out for is that our wireless e-stop, as I've mentioned previously, cuts power to the entire cart when pressed. And then also we have, sorry, not our wireless, our physical e-stop, and then our wireless e-stop disconnects power from the drivetrain. And then here's our 12 volt schematic, which you will also see, which just shows everything that is being powered with 12 volts via the converter from 48 volts to 12 volts. Okay, Another thing we were working on, thanks to Caden, one of our members, is updating our PCB designs. So the STM32 design schematic hasn't had any changes. But what we did change, or what he did change about the layout, is that he was able to redo the naming scheme of the PCB layout, because on here, if you look, there is a J question mark here. He just redid it so it doesn't have a J question mark. So everything has a proper name. That's one of the changes. He also was able to move this wire. As you can see right here, it is running through through or in between these two pins, and that could cause problems when printed if there's a little bit of, the tolerance is a bit high, so that will cause maybe the trace to run into the pins, and then it cause faultiness when we're trying to connect it. So he instead moved it down here to solve that problem. He also connected our J3, so our power connection from here, he changed that to make the ground connection go over here in J4 as well. This was more of a personal choice because it's consistency with our other design, which is on our Teensy. So that's why he made that change, and those are the main changes on the schematic for STM. And then for the Teensy, what he did was basically we downgraded to, well, not downgraded, but upgraded, or whatever you want to call it. We changed it to be just a board that only incorporates the CAN transceivers on there, instead of all of the other ports and things we had on there, because we did face a problem last year where we had problems with our CAN connection, so we thought maybe simplifying it would help with that moving forward. So now, as you can see, the Teensy board, instead of having all of the connections here, we just have 2 ports for CAN transceivers and then the Teensy itself. A bit more of a simplistic design. Then we have our GPS integration, which software mentioned previously. Basically, this will be used to help with our navigating system. So this is just showing it. This is a prototype that I was able to get from Alex yesterday that they've been working on, a prototype of the mount. And the way we'll connect this to the car is via USB connection. So that's what we'll be doing electrically. And the same thing for our radio frequency control, which we'll be using Arduino and then connecting it to the card via USB as well. All right, and Taha's going to talk about our batteries.
All right, our batteries. You've already heard a little bit about this from everybody else, but I will go a little bit more in depth. So, as you heard, we're using lithium iron phosphate batteries, specifically because they are more reliable. They have a smaller downtime, so their charging is a lot faster. As any of you guys who have been on the team prior know that we're testing for like 2 hours and then charging for 5. Not a good time. So they are more energy dense. These ones specifically have 100 amp hours running through them, as compared to the SLA 1156 batteries that we've been using, 35 amp hours, and they weigh a ton, mind you. I'll get a little more into that later. Some of the major features that these batteries have that I selected them for is that they're already IP65 rated, so they don't need a housing, which is great, so we can swap them out easily. We did purchase 2 sets of 224 volts, so we are able to still swap while during the charging period, so we don't have a downtime like at all. Sorry. They also have an integrated BMS system, so we don't actually need to implement one of our own, and the battery's life will actually last. As some of you guys do know from last year, we did have a dead battery, which was causing a lot of drainage, which we were able to figure that out before comp, thankfully. This is a small comparison that I put together from the SLA batteries and the lithium iron phosphates. Now, nominally, they're both 48 volts, and the capacity of the lithium iron phosphates was 100 and 35 for the lead acids. Now, we also did an energy calculation. There's 4.8 kilowatts in the LFPs, versus the 1.68 from the 35 amp hour lead acids. Now this is kind of important given that we have a 4.8 kilowatt motor, and in order to get the full performance, these batteries would definitely help. The continuous current is roughly the same, and the weight is slightly reduced, but again, 3 times more energy dense, so we are still profiting off of this. It has a much, much higher cycle life, so we're able to use it and charge them way more compared to the lead acids, which is only like 500 cycles, whereas this is a couple thousand. And we are able to use much more of the battery safely versus the lead acids. And of course, with new batteries, we need a new charger, as we only have the 12-volt charging system that we have purchased for the lead acids. But here we have purchased a 24-volt charger. So it is, the voltage of this charger is 29.2, just so we could get to that 24-volt nominal. It is rated specifically for these batteries. I actually had the customer helpline for the Wise batteries email me this. So they had specifically recommended this because of the 0-volt wake-up function, so it can fully revive the batteries if they ever get fully depleted, which hopefully will never become a problem, but if it is, hey, solution.
Okay, and then our next steps for electrical will be to implement the new harness, test for EMI, and then work with members for basically implementing things that we can have for the future of Phoenix. What we've been working on that has made it here is PCB design, but we'll work on that more. We're working on embedded systems and also just learning Altium design to where we're putting our schematics now. So, yep. Oh, thank you.
We're now going to open the floor up to questions. I can see that Andy has written quite a bit, but I might want to suggest that anybody else go before him. I know his questions get quite long. Was there? You got something?
Yeah. So about the battery, you mentioned that you guys were having an issue before. So like before I joined, what kind of issues were you having with like the old batteries versus the new batteries are going to solve?
They don't need nearly as much time to charge, nor do they need to, nor will be. They'll also last a lot longer.
Isn't there like a catch these batteries if we need performance? My brain is thinking there's gotta be a
The chemistry is just better compared to lead acid.
Is it just built different?
Yes.
Do you think?
Yeah. Hey, added bonus, they have Bluetooth. That's not why I bought them, but they have Bluetooth.
Okay. So are they like more expensive or?
Not actually. They're relatively the same price, or actually a little bit cheaper than lead acids. But the reason why the lead acids are priced the way they are is because people don't typically buy 4 of them like we do. They are car batteries, so they're priced for like one time every 5 years purchase or something. Whereas these are like camper batteries meant to power someone's electronics in a tent or something if they're camping, or even power an RV or boat.
I guess it really is just built different.
They are built different. Hey, but if any issues arise, I'll let you know.
So the weight of the car, is it currently 404?
I know that you know that number was a lie. We are still yet to reweigh the cart. We want to wait until we get the parts from Miyazaki to reweigh that. But we could also just throw in an estimate using combustion's scale.
Part of what I'm also wondering too, I guess is search line, like how much do all of those components have to put everything on top of each other? Is there like a weight limit?
No, there's a minimum
There's
weight,
a minimum weight,
not a maximum.
And also, we're gonna be getting rid of a lot of the
Have to grow.
parts on there as well. A lot of the prints on there are going away, so we're not just adding stuff, we're also getting rid of stuff.
The battery. Sorry, go ahead.
So with the computer mount, that's gonna be like everything that's currently.
Oh, yeah.
A little bit so, yeah.
And like you said, the battery is what, 1/3 of the old
They're
batteries?
3 times more energy dense, but they're also
They're similar weight.
they're quite similar in weight because I've got them 3 times more energy dense. But they're gonna last longer and have a higher kilowatt output.
I know you guys said that you'd be switching to mostly using the GPS and internal measurement unit like system. But when you mentioned your sensor suite, you guys are still going to be using cameras. to what extent are you still going to be using those cameras for? Is it just for maybe future development with object detection and avoidance?
You hit the nail right. You hit the words that you know. Hit the. Yeah. Sorry. I'm not getting the
Catchphrase.
stuff today. Sorry. I'm not all here.
It's a Friday, I don't blame you.
Oh,
Okay.
that should answer that one, yeah, probably.
Yeah, you should if you want to go more in depth.
You put it better than I honestly. I probably would have put it. It's more so we didn't have to get rid of this ability to have cameras on the cart, so I was thinking, well, we use them. Worst case scenario, we don't use them, we unplug them, we save a port on the PC. It's something that has served us very well in the past. It's going to be very useful in the future, so I saw no point in removing them. And as you saw, we use them for optical detection. Yeah, but you're correct. In the primary navigation stack, there is no cameras. We had talked about it. It would have been cool, but it's more practical to have them. It's something in the future if you guys ever wanted to, use a camera-based system instead of just manually putting waypoints. That's the thing to do. But yeah, it will not be happening on this competition cycle. Yeah. Go for it.
The green dots,
Green
the
dots.
waypoints.
Correct.
How are you creating those, or how are you creating the distance between those?
So the dots, the physical dots, those those are waypoints. So there's a few approaches. There is talk of potentially some in-house like dashboard that we display like ROS-bag data. It will be ROS-bag and recording on the cart. I would prefer to get the data straight from the cart because there will be variance in the way the sensors are mounted. It won't be perfectly straight. That will be reflected in any data that we get off the cart. So if we use that, the error will not exist from our point of view. Compared to using something like film. Even if hypothetically you had a film that was the same accuracy, because I know you saw San Diego last year, they took that little antenna with their RTK and they were mapping the bounds of the track. That means you actually have to align those grids. And if that can be avoided, we would prefer to avoid it. It's just something we believe we'll be able to do. Yeah. Answer your
Will the antennas and the RC, will those both be ready to test by the time you test? Like, will the antennas be here and the RC be ready?
So, RC should be ready. We have last week. Elijah's ready.
RC's ready to push. It's been tested. I just forgot to push it.
Okay.
I have it sitting on this computer. I don't know. I think Elijah probably wants to push it though, so I'll
So, you know when you get the antennas? You guys?
So we ordered. So you talking about the Ubiquiti antennas for the GPS antennas.
Yeah.
Okay, Ubiquiti's. We placed that order this Wednesday.
I had already sent it, but it would have been ordered on Thursday.
Thursday. Okay.
We should be getting them hopefully before the end of next week.
And next week. Okay. Yeah. That's pretty cool.
I don't know generally what the timeline for orders is.
Hard to say.
It's not a big deal. If it's like the next couple of weeks, it's fine.
Yeah,
So-
yeah, within the next
And then from
Otherwise,
there,
it's like-
so I will add, we did some janky antennas. Literally, I went to all, I said, can you cut me, I don't remember what it was, but, half wavelength
Sorry?
or 2.4 is.
I used a single strand wire with a Deutsch socket, which just so happened to be the perfect size.
Right.
So we put together two very small antennas so we could actually get it up and running for testing.
So we made
Testing.
crude antennas, and with that, we were able to configure everything on the software side, other than maybe whatever fine tuning we might be able to do. There's a lot of tools and utilities and whatnot that you can do with those access points. They're very configurable, but for the most part, on the software side, everything is already done with the capacity that we had, which was actually, we got some surprising range and distance from the 50-cent antennas. So when we get the proper ones, it should just be plug and play, and then plug and then play and then document and test. But it shouldn't be a very long process, and installation is a 30-second process. So
I might add that the Taliban antennas were able router, including, so we discovered that if you put a metal object like a support beam from IAVS in between you and the object, it would not work. But, you know, we put one in the lab space, we went outside by the window, and we walked, and we got almost, what, 70 feet?
Almost about 70 feet. The problem was at a certain distance, the beams from the high bay, honestly, the high bay is effectively a Faraday cage. So, pretty much. But at some point you got to an angle with the way we were going with the metal beams all lined up, and it was just flat. But the good thing is, another detail that I think is really great is that because these, they're very good at picking themselves back up after they lose signal, right? So if for whatever reason we lose signal, we get some interference or we get some optical, and they get connection. As soon as they hear each other again, they reconnect and they start working again. And no work from us. So I guess kind of adding to yes, ending all this. Especially if you're not using the camera, it definitely signal the note that happens.
Oh, yeah, yeah.
But to the end of one of the issues I ran into was a lot of topics. Like, we don't really care about QoS normally because we don't have to, but QoS becomes very relevant when ARPA's, like if you're remote debugging with ARPA's or Wi-Fi, if you have that as a reliable connection or link is poor quality, you're going to cause a bunch of buffering on the publisher end, and that'll cause your autonomous loop to buffer in places you don't expect and then stop working. So just be aware of that in this, like, looking at your this next week next. This is something you'll have to make sure that you configure QoS wise on the raw side. I just know normally we kind of ignore QoS, so that's something I ran into, and that's why we couldn't do things like debug and run autonomy because the images were too big and it would go off the link and then the car would just drive in a straight line. So something to consider.
On the same page, just make sure when you're recording with ROS bags that you're recording the correct packages. We had rough things happen last year and the year before. Yeah.
Alex, I have one question from Nathan online.
Hi, Nathan. Long time no see. Setting up the wireless network for comp requirements be where there may be gotchas for the network priority between the interfaces config on the computer.
What did you say?
Say it louder for the class.
Just a note.
No,
So,
it's something else.
oh, wait, which one's the question?
The one that's highlighted.
Highlight. Okay. Setting up new wireless network for comp requirements. Be aware. There may be gotchas for network priority between interfaces. I'm assuming, what do you mean by interfaces? Like between the other, like, computers on the network? Or
Should tell Nathan to go off mute.
You can unmute now if you want.
are we hooked into the?
It is plugged into the speakers.
Okay. Hey, are you
Go ahead. Can you hear me?
Yep.
Yes,
Nice.
quite a bit.
I was just saying, if you've got like Ethernet connections for like a LiDAR, and then you're setting up a wireless router, and you've got like different network protocols going between wireless to track and then Ethernet to sensors, you may run into, I've run into that before, where like default network priorities are not what you expect them to be, and then you'll be like, why is my LiDAR broken?
Okay, I see what you're saying. Okay, I see what you're saying there. Yeah, we'll keep that in mind. I think we'll have the router on the cart, right?
We will, or we
I don't know.
can.
We can.
We can.
We might have the router on the cart if we
We
use
just
the
need
LiDAR.
we just need an extension cord,
Okay.
or sorry, a breakout cord.
Potential for configuring network. I don't know if we will be, just because we'll see what comes of the AKS meeting, because we will have a camera will work. And if the camera will work, that would avoid us. Okay.
Camera for what?
Sorry for obstacle detection, because
Okay, I had a comment on this.
Go for it.
It's not just object avoidance, it's moving objects avoidance, correct?
Yes.
That's a whole nother ballgame than just avoiding a object that is stationary. And I don't know what your scope is like. Just be careful about tackling that monster. Just take the small wins, because that's a pretty big monster to tackle, especially without having a foundation of options related to the camera itself in play. Just, at least in my opinion, prioritize the other stuff at least first until you really like where you're at.
Yeah, no, definitely. The idea is that it's something you can do at the very end, maybe when we have more people to focus on it, like Mark and Elijah will be wrapped up, and so we'll be able to throw more people at it. It's just something for us to kind of more so do.
Play with it.
And it would definitely be cool, but you're very right that our priorities need to be careful here, and we can't avoid, we won't, definitely. Yeah. Appreciate you reiterating that.
Could I get Derek's question?
Yes, Derek. Sorry, I didn't see you.
So, besides, it sounds like waterproofing was a requisite from AKS.
Correct.
What other requirements are they asking of
So,
everybody?
on the software side, so for everybody, it's required to have a wireless e-stop like what we have. They made it standard.
After what happened to Zane.
Yeah.
Yeah.
Almost happened.
Almost happened to Zane.
So,
You were there?
You were there. You're sitting next to him. He almost got hit.
Card went
Yeah.
airborne.
Oh, that's right.
You were like an inch from being in the same spot.
Yeah.
Yeah. So, actually, that's a great point. In light of the Kennesaw card, potentially committing, regicide of ISC, AKS has decided to have no people on the track. So this is actually a really good thing to avoid the mechanical E-band brake, is because if that gets activated, we have to send someone out. And we might not necessarily be able to do that. It's an extra burden that we could avoid. And also it gives us future capacity for braking, not using the engine, because that brake has several control modes, PWM, I think percentage, I think there's a percentage, like a degree angle for engagement. There's various control modes. There's a voltage control mode. So it's the sort of thing that you could have a very simple, or you could have a much easy brake-by-wire mechanism in the future. Yeah, and then, and then RC control is an AKS requirement. We are required to use RC control. That was an AKS. Just more so, I think one of the teams was using a wireless connection, which was botchy. So they wanted everybody to have RC. They explicitly asked us to go and test that connection, make sure that it's reliable if there's a giant metal object in the way. I don't really understand what they intend for us to do if a giant metal object will block our RC control. Pardon?
Another bird in the way.
Could be another car. I think they were more so the bridge. Oh, that's a good point. They weren't considering multi-card when they said that. But that's a good thing to add to it.
There's also the black box, but that's a fully software project now.
It's a solely proper project that we don't even know if it's happening.
Theoretically, according to Andrew, it's happening, but they've removed the hardware requirements for the black box, and it's just going to be a software integration.
So the idea is that it's another node that would have to interface with our robot state. It would give us a permission to go autonomous. It would tell us, the idea is that it would let them, from their race control, shut down the entire track by broadcasting a global e-stop. Okay, yeah, you've heard of it.
Yeah, everyone's systems are so different that I don't know how they would do that.
One team isn't even using ROS. They're using
It is ROS.
Huh.
It's a ROS too.
Yeah, but not everybody's using ROS too.
Oh, well, then that's a comp issue, so I don't.
Yeah, there's
Don't stress it.
for us, yeah, no, ROS 2 node, we'll figure out how to integrate it. It shouldn't be terribly difficult. And then we've done RC, ubiquity, waterproofing, no people on the track from that.
requirements, I'm assuming.
Other than general safety guidelines, I don't think there's much else. We still have to do that fire extinguisher.
They told us last time they were gonna make the documentation requirement, like a requirement for every team. Did they make that requirement? Because they looked at ours and they're like, we're gonna make this a requirement for every team. Did they make that a requirement for every team?
Not exactly, not a requirement.
Oh.
Just a highly advised thing to do. Just like having a fire extinguisher.
If they don't, you just get to keep winning the engineering awards, so.
You get another
we
engineering
pissed
award.
off a few other teams. They were like, they didn't look at our documentation. I'm like, did you offer
Yeah,
it?
show it.
It's like that's how documentation works.
Read it.
You gotta give it.
I'd like to make a quick comment. While the pizza's still warm, you guys can go ahead and start eating, because this questioning is gonna take a minute. So go ahead, go ahead and do that if you're hungry.
People ask on record.
I do have another quick question.
All right.
Yeah, go for it, Derek.
Are we still in general?
Sorry?
Are we still in general questions?
No, we can. If you want to get more specific, go for it.
There was a lot of
So,
time taken off
um,
just because there was rain.
I do have a mechanical question.
Okay.
That very rather large frame that I saw regarding the antenna.
Correct. It's a meter.
What exactly is those dimensions like? Is it really tall?
It's gonna be sitting over the cart, the antenna
Yep.
mount,
Yeah.
to get up and away from the EMI produced by the 48 volt harness.
Mm-hmm.
Is there no mitigations for that?
Again, the motor causes a lot of it, and of course we can't really block off the motor because it gets hot.
Come on, Derek. Sorry.
So,
Remember that.
so how high are we talking?
Probably
It's
just
gonna
up to
be-
the
Wait,
camera-
we can
the camera
actually
mount.
go to the.
It's gonna be a little bit
Go for it.
above where the camera mount is.
You're on a different tab.
Oh, yeah,
From past competitions, nobody's cart
that's right.
envelope space went higher than, is taller than you. No cart was taller than you.
It's not gonna be tall. It's going to just be.
It's not gonna be taller than you.
Better not be.
It's gonna fall over before it gets there.
So it's gonna be.
Okay, Derek, let's put you in the backseat of my car again.
This is in millimeters, so it's going to be like 4 meters tall. 4.8 meters.
Yeah, that's 1 meter.
No, sorry. No, it's not.
It's,
This is going to be like 0.48 millimeters.
it's
Meters
It's,
tall.
it's made
It's-
to
it-
rest on the camera mount.
It's like 0.5 meters tall.
Right, yeah.
It's not bad.
No.
Yeah.
I think it's up like 2 cards with the other cards.
Yeah.
Except for that one card that was like really slim.
Yeah, so I was gonna go to that. So was that Kennesaw that had that
Alex?
really shallow cart?
Pardon?
The
Could you repeat
the
question,
super
please?
small cart, really flat. Was that Kennesaw's?
Was that Kennesaw?
Yeah, Kennesaw was the
Yeah,
like.
so regarding their footprints, right, I know that was a big issue regarding like how we're gonna detect and all that.
Yeah.
Is there like plans for making like a, not rather casing, but rather like a really large quote unquote box for the cart?
Oh, like a whole box?
Yeah. Like,
We actually thought about it. That was how all the casings came about in the first place. But then we had the IP65 things happen, and then there's also like heating. Like if we just put everything inside a huge box,
Yeah.
we're gonna create like so much heat in there. So that's why we decided to like make, like for example, we're not putting the motor in a box. Like we decided to put like different things in different boxes because that's just a better option in doing this.
But all these boxes, are you gonna do 2 layers, 2 shelves, I guess?
Can you go to
What
the
do you mean?
the main box?
Because I know there's you have.
Oh, like a layer on layer?
Yeah.
Yes, because space and, just function, why waste the space, If you don't want to have like a million different boxes if you can just like put stuff on top of each other. This is
Also,
not,
with the
this is not
waterproofing,
the one I
again, we're
want.
using Deutsch connectors for our electrical harnessing,
This
so
is-
they're already waterproofed. So a lot of our wires are still going to be sitting outside, except for the main ground bus and the 48 volt contactor. If you can imagine, cart frame like this, about half of it. This is where our base box is going to be. This box that Shivani's pulled up.
Yeah.
This is going to be sitting towards the back of the cart. It's going to replace where the ESC currently is, which is going to rotate it. And it's also going to have the ground bus and 40-volt contactor. And above it, that's where the PCBs are going to go. We're going to remove all of top card, so it's a little bit more accessible because we don't really need it once this is installed.
Get like a drawing of like what you plan to have the finished product look like.
An assembly drawing?
Yeah.
No.
The reasons because
This is the
there's a
last
lot of things we're just like talking about and updating on the fly. Like we like do this now and then tomorrow we come up with another thing, you know. It's not like everything was like we thought of everything together, but we've been like updating those designs a lot. So that's why we don't have like a set drawing. But after this point we will.
I forgot my other question.
We'll come back to you.
Mm-hmm.
Andy?
Sure.
You want to get more technical?
Oh, no.
I mean, not necessarily. Like,
No?
Oh,
Okay.
I have some general comments just because Andrew's not here and therefore someone needs to take that role. Like, for example, for just kind of like admin side things with like Gantt I looked through it earlier today on the slides you sent out. Thank you for actually sending out the slides. It's not always good.
Thank you, Alex.
Just generally try to make, especially if you're presenting this to other people and so we don't know the context, try to make your goals to something like manager or like SMART goals or like a quantifiable goal. A lot of things like goal is update.
I didn't necessarily want to include that. Cadence thought it would be a good idea to do so because those were some of our main goals for electrical.
It's fine. It's just, but even internally, just something I've kind of matured into with work over time, like that helps make those meaningful, I think, across the whole team. So just a small one.
Yeah. Okay. Thank you.
I think the biggest question I have, like, from a strategic point of view, is, and I ran into this because I did waypoint planning like this on OHM years ago, and the challenge I ran into was two things. One, definitely don't try to set your waypoints off of like a GIS software because there's enough. We work with high enough tolerance where that just doesn't work, and the reason for that, what I ran into, is curves are tricky. I guess now that I'm thinking about it, if you're running on the track, it's easier. But I guess just in general, it sounds like your only path planning is just an interpolated line between the geometry of the points. Just keep in mind, like, and I guess almost a question of like, what happens if it tries to cut the path, right? This happened a lot in my case, and it kind of killed us because we were doing edge detection, and so it didn't run off the path, but it just kind of got stuck. In your case, it would just kind of go off the road. Just, I don't know, something to consider. And maybe the answer to that, from what it sounds like, is just make a better plan offline. But
You could.
just
You
consider
have
your accuracy on that. It's
road
part of the thing.
segmentation. Kind of like what you could do is you set your road segments as hard bounds. So they're more so like checks. You give them a weight, or like the width of the cart plus a small safety factor. And then as you drive, your camera's job is to just make sure, hey, edge of the track, don't go past. And if there's no conflict, it will just go along. And you can just like shift these directly over. But
Yeah, I mean, I'm not even necessarily suggesting you do that so much just because of the scope. I
Mhm.
think what you're doing is fine. Like, you could make it work. Just let me consider this. I didn't consider this, and
Yeah.
so just, and for example, it could just be denser points around curves.
Mhm.
But just kind of from I see.
That actually is a really portion of the where you look at the geometry of that whole curve. And so you actually have to, it's a challenge, actually information, there is greater than certain set point for a curve time record of the polygon in the regular shape. And that's exactly how you guys do it, and you also need to figure out what specific points you can because you guys have a very minimal amount of resolution.
Look, we don't have to use polygons and straight lines. You know, we can do other. Yeah.
Yeah, so I think, compared to PDR, like, you guys definitely thought this through, which I appreciate. Like, I think the one thing another general comment, especially for like the engineering presentation day, I would be more clear what your pipeline is in terms of input. Like, I've pieced together it, but it is we did slam to build a map in the past, which is a lot harder. But yeah, just, the other thing I'd say is just like as a team, have like a procedure and like a distinct like plan or like flow chart of how you're going to get these points. Like for example, if you are running the cart from the app, don't just like hack it with a ROS bag or something. Like have a distinct mode that launches it correctly so you can't mess up the field. Like that's something that really bit us a ton in the past.
That's a good point to write down.
Yeah, I think that especially if you have limited testing, which is something you do.
We'll have limited. So it's kind of the other Formula teams are willing to share same day. So like we're not blocked by them. The university is insistent that there cannot be more than one vehicle on the track. So we're going to be negotiating with the university because it's a block for both Formula teams, especially Formula Electric. They get about an hour of run time and 4 hours to charge. So that's 2 runs a day. They have, I think they said it was 4. Right now they have 4 scheduled test dates, and they have 4 drivers to train. So you have to train drivers, tune the cart. I think we're only able projected to tune the cart and train 2 drivers, because they're required to have different drivers for events. So it's definitely, we're going to work on getting as much testing time as possible. And like the other teams, like combustion might not, like especially electric, they won't be running. Well, they have it Saturday, but they won't be running all Saturday. They'll have hours test windows that we can go in, borrow the track they set up, and get around and collect. But to your point of having a dedicated collection mode, that is something I haven't actually I've thought about. I haven't really been thinking about that much. So that's something that shouldn't be difficult to do. You could just custom lunch file. Yeah.
One, do that. 2, document that process. And
Yes.
3, something I didn't do and I should have done is like build that process. Like actually go with your team, even if it's indoors and you don't make a use of the map.
I see.
Go through that process, find the kind of gaps in that, and go through. I know it may sound kind of pedantic, but that
No,
really,
I agree.
That
I
really
mean,
helps you because if that's a requirement you're holding running,
Yeah.
then you really want to get that down.
No,
I
yeah.
I think it shouldn't be hard, but yeah, I'm looking into it. The other thing I thought of that I don't think is a fallback in this kind of by design, just be careful if it's cloudy or it sounds like you're running in the rain, which is cool or good.
But in theory.
Not in the rain. We still have normal rain days for competition.
Okay.
This is more like if the condition this year is like it was last year, where it's like heavy mist.
Okay.
Where that did cause a couple of issues for some people.
Well, I guess even more so
That's-
in this case,
yeah, on
be
his point.
careful of GPS in those conditions. I've run that in Archon, and it works, but you have like 20-minute lock times. It's horrible.
Yeah.
Your
Wow.
design forces you into this. I don't think there's much you can do, but just keep that in mind.
I looked into it because I was like curious. My phone connects to GPS, no problem. Why does my GPS take 10 minutes? The issue is that it needs to get the data from the satellites. You could circumvent this if you could cache this what your phone does is it caches the information on the phone of its current whereabouts. It gets this from cell towers, and
I
then
mean, that's RTK, isn't it?
it is kind of RTK, but you don't require a dedicated RTK antenna. But I guess we'd have to tell our issue with the vector nav is that we can't tell it this information, so it still needs to calibrate regardless.
You can probably do it, but I wouldn't.
Yeah, you could do it with the dev board, not with the rugged one.
Okay, well, okay, I trust.
At least that's my understanding.
I hope this won't be mentioned, but for any, well, at least on my end, I assume the RC is going to be the same. Path loss over open air, generally speaking, is close to nothing, but humidity in the air can cause interference and can lead to higher path loss. I don't know the data on that. I'm sure I could find one of the table relative humidity link loss, but that is something to consider. So we should add, we should aim for quite a lot of extra safety budget.
I think we should be fine with RC because the clear conditions range is, I want to say, 2 kilometers on the RC antennas, or 1.5. Pretty significant. I think our safety range is like 500 feet.
I would
So
be concerned about the ubiquities.
yeah, the ubiquities. But I mean, if we lose the ubiquities, right, or at least we lose them at range, we could get away with just starting the cart close to the pits and then sending it off.
The only thing we need to do with it is start the cart.
Yeah.
I have a comment, like
Go.
piggybacking on this. The RTK, is that, why are we, like, on the slide it said we're being unique. Is that the sole reason of not using it?
No, it's not the sole reason. It's I think I go over. I mentioned. Sorry. Oh, okay. I updated the other presentation, the public one. I updated this. It's more so that it saves us complexity to figure out RTK. We already have to map the track and get that working good. And it took San Diego almost that. It took them that full half day they were there, and then someone to the next day to get RTK set up. And even if we can, piggyback off them getting the station set up, we still have to get it set up on the cart. And that's just one more thing that we need to get set up, calibrated, and done day of competition every time we want to test. And I would really like to streamline that process. I have never done this before. I know nobody on my team has done this before. Making it as simple as possible, even if that means we need to wait 20 minutes for it to calibrate, I'll take the 20-minute calibration over, an hour or two fumbling around trying to get this RTK connection set up, which long-term is not a great trade-off. So it's something for future to consider once we've mastered, once we were comfortable with mapping and creating maps. That's something, that I'd rather do. At least that was the calculus that went on in my head behind that decision with RTK.
It's like if all the other teams are using it.
All the other teams have a much. They're using it because their antennas they can't get our accuracy with the antenna. Like they have to use RTK in order to get better accuracy. I don't know why they aren't using a nicer antenna, especially considering they have the budgets. That was a question we never asked them. I guess I could. I don't think they're gonna have a solid answer, especially if it's over like a fireside chat. I suspect that it's just kind of a choice that they had. I mean, I really don't know. I don't have that solid answer. I don't know if Andy has input for that. Why RTK instead of why not?
I just wouldn't put the complexity. I don't
Yeah.
think it'll be an issue with this fund.
Okay.
Technically, it's better for a lot of reasons, but like, just don't. I mean,
Mhm.
include that, so just don't.
Okay.
This GPS I haven't had issues in outside of like being stupid and running out of the rain.
Yeah.
That's not your scope. I would stress it. It's
Okay.
You paid for it to be good. It's good. Don't worry too much.
Amar, did you have a question?
Was there?
Oh, Sarah. Oh my gosh, I'm so sorry.
I wanted to comment on the RTK thing. Maybe
Yes.
the other teams, maybe we just didn't think about getting a better antenna.
I don't. I don't know.
I might have just overlooked it.
I would say I would actually. I was more surprised they didn't. I've seen the Formula teams that Ann Arbor Formula for their non-autonomous race car. I've seen what Ann Arbor and Ohio State use. They have a very similar vector nav to us. Nobody there obviously knows what model it is when we talked to them at the auto show, but the antennas were the exact same. So I'm a little. I don't know. One of the big things that they've, I guess we don't want to dwell on this too. Yeah, no, never mind. We can talk later. We don't need to dwell on this.
I guess I can be quick about a bunch of
No,
things
you
that I
don't have to.
Give us slide 21's the next slide.
21. Yep.
This, I mean, maybe refine it a bit more, but I
Yes.
really like having pro-con lists. This is cool. A lot of people do this in CDRs for some distributors in general. I like that team decision making. I like you acknowledging the problems. It's cool. Again, winning the engineering award. That's cool. 22, is that real sim? Like, did you get sim output and then like?
No, this is I believe this was Elijah's. Yeah.
Okay, right.
Yeah.
I was gonna say that's sim output, that's really cool.
As an issue, I was just got Cosmos trying to overlay the map, like different types of maps,
Yeah, yeah,
trying to put points at random, like to simulate, oh, what if our GPS has these points there, and then I'm trying to reconstruct it. Not the most accurate, but that's honestly because my map just lazy. I did this in like 3 hours.
But is that blue line just a scribble, or is that like output or something?
That was supposed to be the part of section. You're trying to like generate vectors of lines to see how accurate it is.
But those are from your logic.
Yeah.
Oh, awesome. Okay, no, it's cool. That's cool. I like stuff like this. It's like
The prototype
you're doing researching. Yeah, yeah. We just, like again, not everyone does that. It's cool. Nice. I like that. Yeah.
Are you guys gonna be using sim for this at all?
Yeah, it's a good question.
It's a great question.
Maybe using sim, or is that kind of like a?
Yeah. It was actually surprisingly. I found I actually googled the documentation. It seems surprisingly simple to set up. I spent a long of time of my limited free time on this. I've spent a lot of it trying to understand the actual GPS system because it seems to be our approach of a super accurate GPS is not standard. So like. The recommended approach is this dual EKF and figuring out what that is, why we're doing it. It would be very sensible to set this up in sim. I will see what I can do. I don't, because as of now, I'm going to try and set it up for reality first, just because we are so close to testing. You set it up in sim, and by the time you set it up in sim, like you're already able to test on the ground. Might as well just go out and test on the ground. But
I think
there's.
You kind of are simulating doing stuff like this.
Yeah.
I think as far as what keep from here goes, I think that's fine for what you're doing.
Okay. So sim.
Because the point of sim really for us has always been to try to just iterate early and catch design flaws in like the logic.
Mhm.
Yes, there's some point in like the crashing, but like yeah, like you're right. The real world is harsh and different. Yeah, I think it's fine.
I would like to add something in that. So the side quest of model predictive control will require sim simulations. More of that is because of the weights in model predictive control are so random, and we need to tune them. So what we can do is like run around the lab multiple times, record the RMSE error, and use outer optimization like a particle form optimization to improve the weights and RMSE.
I would be careful of how accurate it actually is for something like that. But I love that.
But for initial results, we need to test it. Otherwise,
rather
we
than
go
random
crazy.
variables. Yeah.
We don't want to blank out.
Yeah, exactly.
Or spinning out underneath his corner. I just don't know how they pull that off. It's crazy.
Really hard players.
But it's just like it's the third corner. It's this long 180 radical churn, and then it goes into switchbacks, and on the exit to the churn, whoop, part 180 itself. It's very decent. They couldn't figure out what was happening.
I would say, I guess, just for sake of time, useful, sort of like the other big things that I think might be more interesting. The gearbox, the steering motor, the slide forward. I'm just kind of curious. I think this is the original one we put on.
Yes.
That's been going for a hot minute, and we're getting to it. I would just be careful how maintenance looks like on that. We never designed well, and so it stayed alive, and that's very cool. And I'm glad that it did. But I would just consider having a spare, as well as having spare, like the key lock, like the collar thing.
There hasn't been much issues with it.
Well,
but
well, it is until it fails. And
Yeah.
we have had that in the past.
Knocking on wood.
Where the gearbox, it leaves red. It leaves. Just a-
Following up to that, Andy, if you're suggesting that we get spare parts for it, then where do we find the schematics for what was designed previously?
The top right, if we can find that file, that should have the.
Okay, this should be in the drive then.
Actually, I have a question for Andy.
Okay, go for it.
Well, I mean, you're saying for the collar?
Where's the piece?
Because the gearbox is like a.
No, you can continue. I'll go after you guys. This is from Caden, who is unfortunately, he is with electrical today. He wanted to know, what is like the purpose of all
What
of
happened
this? Like, he was. Okay.
So maybe expose yeah, I think it's fine to reduce it. That's a very standard thing to do.
Okay.
Yeah, we didn't know what we were doing, and so we were like, take it all.
Yeah.
This is a Josh like side quest when he
Okay.
Yeah.
Josh, that was the guy who designed it. Okay. Yeah, that's what I sort of told him, is that I suspect ISC didn't know what they wanted to do with it. So they said, do everything with it. And, yeah. Okay.
The other big thing was that parking brake. I think Alex kind of got to it. It's slide 46.
Yes, yes, that was
This
a.
is cool. I like you guys have researched it and have some mechanical, because we've talked a lot about this and then. no one
Yeah.
researches it.
You had me reconsidering it after talking about it for PDR.
Yeah. Okay.
So the suggestion was made that we go for electromechanical instead,
Mhm.
so that we don't have to deal with fluids.
Yeah.
Because fun time.
I've blown that up twice. So.
You have told me.
I was not aware.
You can't tell us PDR.
I had just assumed it exploded. I didn't realize it actually had.
It's still, that's probably staying on the floor still.
I wouldn't doubt it, given they never cleaned the lab.
Don't use hydraulics.
Yes.
The only thing I'm wondering is this being a parking brake, which is cool. That makes sense. It would be electrical. So that is something you can digitally control. To various
So,
things. It's not just like
yes.
May I?
But me and Vishran did all the
Okay,
research.
go for it.
Okay. Me and Vish, I was very conscious of the fact. Oh, sorry, Vipul. My apologies.
He's not good with names.
If you didn't notice. So, I was very conscious of the fact that the linear actuator had no clue where it was. So it was a hard constraint, and it shot down, I think, the first few mech proposals. And then we looked in, yes, so it is electrically controlled. The actual, so this is the caliper piece, I believe, or I think this is I'm not sure. This was the piece.
Caliper, this is the actuator.
Okay, so the actuator piece does know where it is. It was a very deliberate design choice to have all the control modules. Thoughts for making it electrical based is that it does take voltage, or it does take PWM. So if you don't want it to be a dynamic brake, you could make it in a wholly electrical system where close is just 100% PWM with like an e-stop signal wire or something. The disadvantage is it won't close if the cart loses complete power, which is a significant risk, but it's awesome.
But there's no one on track. So you lose
Correct.
the
Okay.
There's a couple different things we can do to work around this.
All right.
That we were discussing with Cadence. Cadence, did you want to?
We were talking about using a relay because it's kind of what Laura did previously. On there you can implement a normally closed system. So we're going to try to implement that. That way it'll always be free.
Nice. Okay. I was gonna say this is essentially the commercial version of what Jade made, which is cool. Nice. I like that. Yeah. Yeah. Because I was thinking it's a parking brake. That's the whole job. Actually, it's a park.
Yeah.
Awesome. Yeah. I'm excited to see that happen. This is be a good improvement. But the
You
other thing-
should come to competition with us.
That's my work decision. Hey, you can decision that way.
Yeah.
You can come again too.
We'd love to have you.
For
I
sure.
would say I'd love to go. Will I go? Not my decision. Does software plan on using the brake at all? I'm guessing not.
So,
Included at all?
yeah, I was made aware of the brake decision late into, I had already finished up my CDR slides.
The break decision was late. So.
We really, so the big issue is that technically AKS doesn't allow motor braking,
Not
that
as your
being
primary, no.
not as your primary braking system. So we were aware that you should use a brake. I did do a pretty deep dive into Phoenix IO ROS. I saw there's brake code in there. It's something I don't know how hard it would be to retrofit. I didn't look that deep.
So you have to rewrite the controller.
Okay.
Or, well, the bigger thing is that you have to, you guys can do, because you actually have the coder done right now.
Yeah. Well,
You can do it from I think have to somehow, from somewhere, tell the cart to brake, right?
Yeah.
And so you have to, I would be in MPC logic, I guess. But I don't know how it would choose that. I think that might be at a higher level planning, maybe. Just a thought of.
We can always kind of cheese it. Just look at, like, you know, if there's maybe so solving the encoder. I will briefly touch upon it. Yesent. It reads backwards very strongly. It doesn't read correctly. There's a significant difference in between the observed and actual speed. An inspection of the code brought knowledge that the circumference of the tire was incorrect. We corrected this. However, the cart is still currently, electrical is redoing the harness, so we have no way of verifying it. What we did is we put tape on the tire, tape on the bumper, spun the cart, counted frames. It was, thank you, Caden, by the way, for counting all that. It was.
Caden even together a very nice graph for us on Alex's laptop.
Yeah.
So we were tracking correlation from different speeds and how off the software was.
We found it was a consistent factor, so we decided that it was definitely software and not the encoder. So yeah, again, to actually, there's a bit of a thing with the encoder will never read 0. I solved this with a dead zone and then tuned the PID with just P, so we now have a stepper function.
In LPID though, so we can still do it on ground.
Yeah, that was an in the air, but okay, but to the point of in the air, the issue with the previous back one is that there was significant oscillations in the air that were only mitigated due to the weight of the cart on the ground. In the air stops. Like, yes, there are oscillations, they're imperceptible. So I'm actually really happy with what came out. I solved this. I put a dead zone on the encoder. It's 0.2 meters per second. So if it's within plus or minus that range, we just call it 0. That's good enough.
In the real world, the cart testing in the air, we disable the Kalman filter. In the real world, the Kalman filter will compare with GPS, and you won't have to do that because the air from the encoder filters when it uses the Kalman filter to counteract that with the other sensor. So in the real world, I don't think they'll actually need that. I think there might be testing like a harsher environment if you're only using the encoder for speed control.
Okay.
Yeah.
Well, you know what? We'll take that. Okay. Yeah, cool. Yeah.
Okay. So about testing, you mentioned something about like the race controller, monitoring stuff. How much of that have you worked with? Have you made like testing dashboards? Like, remember when we went to the Massa CDR?
Yeah, NASA has a dashboard team for, gosh, what do they do? They display telemetry. Yeah. Oh, yeah.
NASA member over there.
Elijah would know quite well.
Anyways, what I was saying is, do we have something like that?
We do not have our in-house dashboard. We don't have any sort of that. We rely on, so debug is still done through Arvis, so we publish topics. It's really just hybrid fear pursuit. We haven't built off of this since the 2023 cycle, is that we publish topics that contained important data, and we're able to visualize them in Arvis. The advantage is that this is what the cart is seeing. You're seeing it through the eyes of the vehicle. So it's pretty, whether or not the information is accurate is another story, but it is what is happening, which is a bit of a ground truth in its own self. But yeah, in terms of other dashboard systems, no, we have not considered it. It's actually, no, we'll talk after about it. Okay.
And I think my second question was about the RC control.
Yes.
So by RC, you just mean like
Radio control. You
you
see.
like one of those toy cars we had as kids, right?
So it's a radio protocol.
Yeah. So what exactly is this used for, other than I'm assuming pushing the car onto the main area?
Yeah, I mean, that's what it's for. I mean, there's scenarios where, especially AKS is, we can't move autonomously in the pits, but we're not allowed to leave the confines of the tent. So RC control will be how we navigate the vehicle from there to there. A bit of comments I think we forgot to mention. So the controls of the RC, this is a drone controller, which means the left joystick, the up and down access does not have a spring in it. So if you put it all the way forward and say that was throttle and you drop the controller, there's nothing to stop you from that. So we have mapped the controls to the right stick, where if you let go, it resets to 0. The concept being, you know, in case it's sort of a dead man switch to prevent it. There are these levers up here. This is channel 5 up on this one. This one here is channel 6. Those will act as our e-stop, or is our on-off modes. Heck, you could use the other one for even just keeping the car off completely, like just disable all speed, like a software emergency stop. That's a potential, but not required. That's not an RC requirement, but that's a potential thing to do. I don't know. Okay, I saw 3 hands. I'll go Derek, Andy, Jared.
You might want to write down your question, Jared.
Okay.
One, will we eventually be seeing through the eyes of Phoenix this year?
So
Using that camera that we're kind of not using, but using?
there is maybe. I think it would be incredibly useful to use the Phoenix camera to help navigate the cart. I talked with some engineers about just how the protocols, how they do these with drones. It would need, ROS is not going to be the method to facilitate that. We would set up some sort of socket programming with UDP, broadcast that on a port on the cart, and then, you know, your base station can listen to it. The FlySky does not have an interface that could display it, so you would need another computer, or maybe something like a Steam Deck, you know, because that's got all your controls. But you could, yeah, if you wanted to do VR, I have no clue how it would work, but...
At this point, let's just buy a full gaming PC.
Are you still there?
Don't you have the
Yes.
the lab?
Oh. No, Nathan left.
No, wait, that's not how.
So I guess that would be pretty important if we're confined to the pits.
Mm-hmm.
It'd be nice to see what Phoenix is seeing so we could drive it when we are in RC mode.
I will...
This autonomous mode to kill it in advance. 'Cause
Yeah.
I think they only allow up to 3 people on the bridge to begin with.
They didn't have a limit. They wanted 1 person from each club, they said. Was it 3 people? Okay.
They wanted
Because yes, it's much easier to drive from the bridge. I would much prefer to do that. I'm still a little annoyed they're not letting us do that.
and also since we can't have people going in and off the track, they wanted the people.
You'd be
the
up
whole
there
time.
for a set time slot, and then, you know, if you need to cycle people out, we'll have to dedicate a time during break, like a 5-minute pause. Okay, get in, get out, recycle your people, go. And, you know, you gotta go to the bathroom, you'd have to hold it. Something which I think would be cool, but I don't... Yes, that is on my mind.
It's an idea.
It's something that I know that we really ought to do. The exact implementation, I mean, like, it's all a priority here, you know, it's...
That would be even more of a priority than the side quests that you have.
I do, you know, that's a very valid point, come to think of it, is that we can rearrange the priority, the order of the side quests. It's something we have actually begun tracking with a backlog for these sort of things, and we have sections on them, which are due dates, but in practice they're much closer to priorities for when these tasks have to be done. That's something I will add to that. I will write down right here to add that to the backlog.
Good segue to my second and last question.
All right.
The Gantt chart. Could you go to that slide real quick?
If you're going to talk about ISC software, I can say it was a quick draft. I'm well aware that it's missing several things.
Okay.
Oh wait, no, I lied. We did add these back in. Okay.
Nice.
Sometimes I forget myself.
So I see this very long line of long vertical line.
Correct.
Of green items.
So that was supposed to be the first. Wait, are you talking about the
dark green?
No, he's talking about the light green.
Oh,
Like
okay.
green in the software, like.
This one?
Yeah.
Yeah. So that was supposed to be like first testing. So that's the deadline for RC. The nav, at least the first iteration of the navigation stack. It's like all done by our first on the ground autonomous testing. So that was the point of this line. It does occur to me it was not labeled. So my apologies on that.
So, okay.
From what this Gantt chart says, yes. I'm not gonna lie to you, Derek. We put this Gantt chart together fully this week, so everything on here is on track with what we are doing right now. But looking at the data that we had prior, no.
The software Gantt chart, the one that we put out in January, is still on track.
Okay. Oh,
But
that's good. That's really good.
yes, yeah. So we're doing we're doing all right, all things considered. There's definitely.
My only last concern is that the mechanical things are ending after the first test that you have with your software. Am I understanding this correctly?
The software in-air tests can be done without all the mechanical components in place. Because the mechanical components are mostly just the housings, and they don't actually need to be there unless it's wet and we're testing in rain.
Well, okay, so then what are you testing then, if not the signals and the antennas and all the other things?
So the nylon 12 material that we're making the harness out of isn't actually mitigating EMI. So it's not actually too. Well, hold on. Can you ask your question again?
Yeah, so looking at mechanicals, they seem to correlate after the first very long or like software's due dates.
Again, mainly mechanical equipment is being manufactured by Yazaki. They're taking a minute to get back with us for a lot of their parts. So their integration can't actually start until we get that equipment. So this is more of a what's possible at the moment.
I feel like you need the mechanical foundation over the satellites and everything for the antennas and everything in order to test that software stuff that you want to test.
We can put together a prototype bench pretty easily, where it would mimic the conditions of competition, where there shouldn't be too much of an issue with rudimentary testing for software. We have done that. We've been testing GPS waypoints with the piece of wood that you saw a photo of earlier.
Yeah.
It's actually in the lab space. It's literally just a large plank of wood with two 3D printed mounts spaced 1 meter apart. So we could get some test waypoints. From center to center, 1 meter.
Not the most elegant, but
It really isn't, but you got the job done. If I can find it. Wait.
as long as it works. As long as it works.
I actually don't know where it is. What slide is it? It's in your slides?
Yeah, I think, yeah.
Where?
Somewhere. Down,
Did I pass it?
74.
Oh, I see, yeah. Yeah, so you can see center to center 1 meter. Yeah. Yes, so this over here would be the front of the cart. This would be the back. And as what Alex told me is that the antenna should be facing the same direction, so that's what we have set up.
Oh, and we found no interference.
Yeah, not yet.
I mentioned
We're going to do more rigorous testing with the motor on and see if that causes an issue. Because the motor, again, is always going to be the biggest source of EMI.
I really feel like some kind of guard,
Some EMI shield.
some sort
We
of.
could use Plexi.
We talked.
That does technically deflect electromagnetic signals.
You don't have to do a DD on the casing of the motor, but rather casing of your other components.
I was thinking, Robert
I wasn't saying like a
suggested
full case,
encasing
but,
the antennas, because at the end of the day, that's just a receiver node. If you put something like aluminum foil around it, you know, it's like, gosh, what is it? Like putting aluminum foil behind the TV wires, you know, back in the like 50s or 60s or whatever. It's that sort of setup would help concentrate the signals and it would reflect them in. It's something to consider. You also have, you know, drag mechanical characteristics. If you add, you know, basically a metal dish, you know, onto your antenna thing, right? How well is that going to survive motion at speed? You know, so it is on my mind. I just, again, with the cart down, we
knew we needed to do EMI tests, but we've yet to get to them. But it's definitely something that we're.
My only concern was the fact that like certain like mechanical was usually after what you needed to test before you needed to test something, so it's like kind of like a weird timing situation. That was it.
Yeah, I can't speak to the Gantt chart or how realistic those timelines are.
Again, they're mostly based off of what's feasible at the moment.
So those are
Reasonably feasible, yeah.
Are they? What is the actual? Are we going to? I don't know. Okay, sounds like a later.
It all has to do with the timeline of Yazaki.
Yazaki print. Okay.
Because they're the main bulk of our prints. Andy?
Yeah, I guess just kind of like random high level things, because I think we've looked at some things. I think my big theme would be, honestly, like you actually seem to have thought up the design, which is really cool. Like I think it's not scoped to a level that's being hand-waved to the stage, which is frequently kind of. The big thing would just be get processes down, like non-like operations.
No, yeah,
And
I'm
just like even if it's on the cart and nothing's technically working, go through the motions of how you would start, of how you would run it, of how you would map.
Yeah.
Even if it's fake, like
Definitely.
find gaps in that early and fix it.
What prompted me to even initially begin like the whole we need to test early test off this is kind of back when I was a lifeguard. I was certified under Ellis. If you're familiar with the difference between an Ellis lifeguard and a Red Cross lifeguard, you will understand what drove me to make that kind of testing. Ellis guards do weekly refresher trainings in order to keep your skills up. I would say by like my third week on the job, everything was automatic process, and that's the sort of I'd like to get at least 2-3 people on software up to that stage where it's just automatic, it's go. If you're familiar with the storming, forming, norming strategy for, I want to get us up to performing. I'd like to have leave it all, do it, make the mistakes in testing so that we get to APS. We're just an oiled machine. We're knocking these out. That's the.
But even if you don't make the mistake, you still have documentation.
Exactly. This is true. Yeah, documentation. You're right. That is something.
I've kind of heard this a lot. At Toyota Ritz, you should be developing your processes to the point where you don't necessarily have to think about what the process is. All you're thinking, like, you should just be able to like do the process, but all you're thinking should be how can I improve on this process? So you made a good point. It should just be like in your head, but you should always be thinking, hey, how can I make this better? And I mean, just looking at this, I can definitely tell like there's a lot of things you guys have been considering, like even from the past generations doing this project and over the last like 4 or 5 years. It's been a lot of build up to like what you guys have right now, and that's pretty evident through this presentation. I think it's pretty cool.
Was a direct reference. If we cited sources at the end, Om would be there. Because that repo is where I found that we have a GPS driver for the vector nav that I use. Yeah, I was like, that saved me a lot of work.
That was like the only good part of them. So.
Yeah. So.
The only stable part of them.
Did you have a?
I was just going to ask about the E-brake. Because you were mentioning about how you don't want to manually reset the E-brake, but did you say that you're changing the E-brake?
Correct. Well, ideally we're going to use the electrically actuated brake, so that the idea is that it's controlled autonomously by the vehicle.
So is it still pressable though?
Yeah. So the flow chart, depending on how the electrical switch works up, I'm not going to speak about complete power down state, but the idea is that when the wireless e-stop is engaged, the parking brake will engage just like the mechanical brake, regardless of whatever software says it's going to do. I would prefer it to be an electrical system. The design is not yet finalized, so we're not sure how if we can have it just be like a signal wire to shut the brake down or something. We're not quite confident if we can pull it off. If it wouldn't, if we need to integrate processing power, it would happen on the STM, and the STM would just be changing the input codes because it would be reading the e-stop signal tape and then sending the correct node to, or the correct information to the brake. But the idea is to,
That's a good question, actually. I think, but just on this diagram, for example, there's no brake controller. How are you controlling the brake?
it's a great question. We have not yet gotten to that. There is no, I have no plans to integrate it into the software stack this year. I think it's too much, too little, it's too late for it.
So we'll just be keeping what we had last year?
Yeah, it would be keeping, in style. I would really like to get rid of the band brake. I think it's not effective at the speeds we're operating at.
Yeah, because I don't think it's ever really solved. It's
Yeah.
more of a requirement that was kind
Yeah,
of.
it was very much, in our case, it is, at least for when we ran the cycle, it was a requirement checklist.
Yeah.
And also, it would also give the university a lot more, like, they'll feel a lot more comfortable with us testing at speed.
Yeah, I would definitely just put in at least a thought of how you would interact with that brake controller. I've never worked with brakes that are like commercial like this, so I'm not sure how you interface with that. Presumably it's either on CAN or it has some protocol, but just I guess communicate with your other consultants, because I would definitely still work on that even now, or else it'll just keep getting kicked off to the next year. And I think, like you mentioned, would be a huge gain for the whole team.
It would.
And also it's just cool, which,
Yeah,
we have
actually,
brakes, let's go.
You have a full drive-by
Like,
wire system. It's the
we
last
have,
thing
we have a working
Without
vehicle.
rules, like, resting on
Well,
your
I could
face.
stop once.
I mean, if you think about it.
Sacrificial, like a semi
You
truck.
said you blew it up twice.
Well,
2 times.
we had to rebuild it.
Oh.
And then bleed it. Like, do not bleed a go-kart brake. It's awful. Thank you, Jaden, for that. Yeah.
Did it bleed the brakes? What did you do to the hydraulic fluid?
We blew it up.
Oh.
And it was on the ground, so you have to bleed the line and put it back. I forget how it works. I'm not a mechanic. The other just kind of random positive comment. I like the trend towards kind of research that isn't just text on a slide and like we have graphs, and like the RF stuff is really cool. Like that's I mean I'm sure NASA does that, but at least in our team, that's very boonga boonga. We were just like one route around the cart, go. So I think that's cool. And it's the same with like showing graphs of like really early logic response. I like the trend towards that. That it's definitely feels a lot more professional than like the last 2 reviews I was for here, and especially for like the engineering thing. Like this is a really cool, like it comes across as convincing from my point of view. So yeah, I think that's a really nice trend. I definitely keep up with it.
We are professionals, right?
No. We're a hobbyist.
Some may say, emphasis on some.
Oh, relative term. Professional implies I want a job.
Professional means
Professional on the
professional,
resume.
not.
Exactly, exactly.
Professional on the
Gonna give
resume.
him
That's a good
50%
thing, Mark.
Professional.
$0.
0 times X percentage rate. Actually, I do have a comment for, wait, I had it on top, I forgot what it was.
You got any more statements or questions, Andy?
Oh, I do remember. nav2. You guys use nav2.
Please don't.
Okay.
Netscape's matured a lot. It's not bad. It's just, I think at our level, it kind of takes away from the core point of ISC where it becomes YAML engineering and you don't actually really understand what's going on. And it also really needs SLAM, and SLAM is just something that we've never had the engineering design ability to work around. It's less like technically you can use it, but in the same way I mentioned like processes for starting up like learning mode or whatever, it's hard. You have to do that. So, but it is a good code base. I forgot who the maintainer of it was. We would chat with them trying to figure out how to work it.
nav2.
Yeah, but I think it's just it would solve the problem. It did solve it for us, but it's just obnoxious, and I wouldn't recommend it. But it is technically an option. It's just not as interesting from the point of ISC, in my opinion.
To be honest,
But it's
I
helpful.
kind of wanted to, my thought process for not using nav2 was to just keep the robot as much in-house as possible, which is why NavSat Transform, I was as salt is part of robot localization. I'm like, okay,
Just don't
that's
write
fine.
your own email.
Yeah.
Just don't waste time. It's awful.
We did have a proposal from a mass member who was written a few common quotes on it. He was like, I can do this for you. And I was like, I'm not doubting your ability. Because he's a very, this is David. And I'm like, I have no doubt he could do it.
You said you proposed a comment?
He said if we ever needed a Kalman filter, you know, just let him know.
I'm pretty sure David referred to our requirements being very basic.
Yeah, but what I told him, and kind of leaning on to this, is that the Kalman filter, I wanted that to be something that's sustainable someone else goes. Because it really, at the end of the day, the whole point of the ISC is to kind of keep the project going, so more people can learn beyond you. And if you write something super complicated, like your own Kalman filter, and it's you who documented it, you know, the usefulness is the documentation that you wrote for it. I don't doubt his ability to write competent documentation. I doubt my ability to make sure that I can ensure he's written enough. So I like if you keep something open source, like you know, robot localization, there is a community of people that you could pull from if you really needed to. Whereas you know,
Yeah, I would say don't underestimate also how much that's doing for you. That is using the Kalman filter because like OpenCV has a Kalman filter as well. Like that's not that great. I mean, the hard part of an EKF is you're linearizing something, and so technically it's for a mechanism like kinematics or whatever you would call that, where you can translate Y. So technically, like the system that Kalman filter isn't actually very accurate for us at all because we're acronym. So I think there is actually a lot of improvement that could be done there. But the ROS half of it and like publishing the transforms and managing all that is actually a pretty significant effort. I think the Kalman filter half may honestly be the easier engineering half of that, just because it's like a math problem. So yeah, I think that's the right decision. Although it's a cool side quest if they want to do it. I mean, it's fun and I like people doing cool stuff.
yeah, I mean,
Yeah, I think do a lot of stuff.
yeah. Yeah, that answers that too. I'm trying to think if I have more questions. Are you guys have more questions for us?
I think I'm pretty satisfied. I'm all set. Or actually, I have one thing.
Go for it.
I was going to mention the cadence. In one of my list of shoutouts, these diagrams are so much better. Thank you. I know why they looked like that before. I was there when it was written. This is so much better and like legible and like I can understand it. I would definitely still do a second pass. There are some things like the steering and drive motors are both labeled steering motor. Little things like that. I think before you should really do a judge. Please do that. Also, something that the judges complained about. Title it.
Okay.
Because we handed them the binder and they're like, "What is this?"
Yeah.
Small detail.
Okay.
And then as well, something that I'm guessing is also just a like typo or something, but at the very bottom, there's a 5 amp fuse in series with a 250 amp fuse. I don't know the reasoning for that, or if that's intentional. I'm not an electrical engineer. I just saw it and was like, I don't know what that is.
Yeah.
But just again, a
I
small
see
thing.
it, yeah.
Take a look at it. Or
Yeah.
this is the point of a review like this. But yeah, just little small things like that. I mean, maybe even to catch more stuff like this from an EE. Just you go to even a professor and be like, hey, read this. Anything look off? Because like they'll catch something like that too. So, but anyways, I like the trend. This is really cool. I like the progress a lot from where we were just a year ago.
I'm just say that progress from a year ago. There's a lot. You guys are working on a lot that is changing, and I'll just emphasize to focus on what you need. Try to get that scope.
Yeah, so I think your current scope is good. I would honestly ignore your side quests for you. Like I think the MPC stuff is cool and like we literally need it. So keep at it. But I think like the wheel to wheel stuff and that like there's no way you finish this stack completely in time. It never happens. It's never happened. Don't even worry about it. Like that's a summer problem for you. So that's your summer research if you want it.
By summer, hopefully, I don't know. I'm out in the
Well,
world.
so
if I'm not, I'll keep
anyways,
it in mind.
point being, I think you actually
why I'm trying, we'll hopefully, like, leave the development for that after. But you did raise a good point with the process that, you know, if we do, you know, yeah, we developed the system, that's great. Can we use it? And if we, you know, neglect that to add more features, you know, that's the textbook definition of technical debt, any way you look at it. So, it's something we have to keep in mind. We'll see, because I really would like to. But if it's, you're right, keep feasibility in mind. But
Here's the goal. Get around the track once during the actual competition. Hasn't happened in 3 years.
Right.
No, that's our card side.
We almost made it, Andy. We almost made it.
No, we did not during competition, but we did send it.
Farthest we've ever
final
gone.
day, and we made it around the long curve, about halfway through. Where
We made it
Both,
halfway through the
both,
track.
both of ours, we did it, but just not at the actual competition itself,
And you're
like not
right,
the
yeah.
actual race itself.
and-
We
and
made it from
hold
here. Made it all the way here. Right? And from here we crashed out. Go straight ahead.
Has anyone actually finished this?
Yes.
Oh gosh,
Oh,
you
the
see
other two,
Berkeley pulled it off 2.5 laps reactively.
Reactive,
the
yeah.
same year we failed on the first corner.
They're insane.
No,
They're also
we're-
DNF, but their DNF was a lot better than us.
So everyone was DNF, but
They were
Berkeley.
No,
flinging it around
no.
that
Two teams
track.
did it, but only Berkeley did it reactively. The other two teams did it GPS based,
Like we're doing.
like we're doing this year.
Correct.
Last year we were reactive.
Hopefully.
Well, we still have room for more reactivity. But
Yeah.
Hopefully we finish this year. And very hopefully we win.
I know about that.
yeah, I also
I wouldn't even fight on that scope. Like,
What about winning our program?
Frankly, I prefer reactivity over
They're
GPS.
not even, they're not
More
even
impressive.
like peak as some
But not my field.
Like, they feed into Indy autonomous.
Yeah,
They're just this is their warm up.
tiny card.
Yeah.
You look like a converter.
You can
Yeah.
hear yourself
It really is.
If we get around the track,
The pink one makes you look like a converter.
Bruh.
You should ask Cadence about
I
that.
just saw your tiny car project on like the Ross Tunes thing, and they were showing us this thing, and I'm like, hey, that's System 76, and Derek's like, that's your labs, that's tiny car.
Wait, it's on set. Wait, that's awesome. Wait,
And they were like,
send me
it's
this.
such a cool. Oh my gosh, I'll have to.
That's so cool.
They found a post from 2022 about it. They were like, we're thinking of doing this. And I was like, dude, do you want it? Like I can send you all the
Was it
information.
not F-110? F-110 was very much a thing that is not made by us.
No,
Very
it was
sad.
us. It's like
Was
it
it?
had our tiny car.
There was a
It had the
photo
power
of
strip
the
from the
tiny
lab
car.
space.
in the
I must have been.
No, you did.
You did. It was your
Centers
thing.
made by Andrew Levega.
Wait, on what?
I don't know.
It was
I
some like
I remember
stacked
seeing this.
form.
He saw it too.
What did I do? Okay, we're fine.
I knew System 76 was in the shot. Like I knew it was us.
Cool.
It was pretty extensive too.
Yeah. No, it was like 5 paragraphs, 8 paragraphs.
Was that the framework for it? Because I've heard the framework main board.
We'll have to look for it.
Anyways, yeah, I'm really curious.
Anyways.
They decided to go with Donkey Kart because they were already using Donkey
That's
Kart.
what we were gonna do. We looked at it, but it didn't work because we didn't have small highs run shorts or.
Oh,
and
yeah,
so
that would have been rough. So wait,
Wait, where'd you get sent to?
No, we made it. That's it's literally just a STM board. RC card. And it's remarkably
I mean, good enough to.
it's extremely simple for like relative, which is good for.
Right.
Jared, did we get through all your questions? Good.
Wait, is Danica still alive?
Yeah, we're running it next week.
Nice.
Well, we're trying to work on 200. I just time.
Take videos, post them on YouTube, and send it to alumni.
Oh yeah, I was
Tiny
gonna
Kart?
say, just in general.
Or just-
especially if you get anything working, put it
Yeah.
on the YouTube
Just
channel.
put on the
Yeah,
YouTube channel.
I noticed you
send
guys
it to
had a
people.
lot of old footage of things working, and I'm thinking, maybe we could. That's what we'll do. Motor test. We'll do a motor test.
With Tiny
Then
Kart?
we'll e-stop it, because remember, we got to
Oh.
fix the IO bug with the Robotech.
Yeah, yeah.
Once we do that, we'll e-stop it, unstop it, and then it will go again, and everybody can cheer, and then we'll post it. No context, by the way. The title will be like, yay, or something crazy.
Andy, about Tiny Cart.
Yeah.
Mark is the guy who got the farthest in it last semester. The only reason he didn't finish is because he pulled him onto Phoenix.
Yeah. Oh. Well, I mean, they bogged me down to getting too advanced. They figured out.
That's the goal of Tiny Cart. I'm like, the goal of Tiny Cart is no one ever finishes.
I'll be honest, I'll be so real with you.
The moment you become viable for Phoenix, that's where you're going.
That's fine.
My
Yeah.
code was garbage.
It
It,
is
didn't
wrong.
work, and it probably could not, in its current state, complete a lab. But
Mine also did. I hate it.
I got to the point where it was kind of working, except for some extremely weird reason, buried like 5 layers deep into like the embedded system, like into the libraries or something. The algorithm for calculating merge turn could not output a negative.
it's still bugged. It's still like that.
I still haven't figured it out.
I haven't figured it out either.
I
Because
learned
crazy.
I spent about a month and a half trying to debug it, but I gave up and then decided, screw this, I'm going to Phoenix.
Do you know how I
Well,
solved
you know
it?
what's the good thing?
We have an if statement to check if the target point is negative on was it X or Y, Derek? What was it?
I forget what it was.
I think it was Y. We check if it's negative and we just invert the steering command.
Really?
I don't think that works, because if it's...
Oh my god.
No, it didn't work, by the way.
No, it
That's the
doesn't work
funniest
because
thing.
it's not, that's not the
It
right
has to
method.
be the servo control.
It's not just, it's not even
I mean,
the servo controller, it's the way that it works. Because if it was like 1 to 10, and then negative...
Oh no, I mean negative. I invert. I mean just like I would put a negative sign on it.
Oh, yeah. But no, it is broken far past that
And then,
level.
then it could
I
turn
wonder if there's
right.
something like
Well, no, what I realized, though, I came to a better conclusion, which is that
turn left.
the cart turned one way, and it's like, only right turn on the track.
Oh yeah, that's true.
Alex.
So I don't have to worry about it turning in both directions.
This is what
It-
it's designed for your recording.
Except for the obstacles that they do.
And I was gonna ask, like, if you always feel like left,
Alexander.
like bad car.
Yeah.
I want to pull this back towards Phoenix. Is that fine? Can I pull this back towards Phoenix?
Yeah, go for it. Go for it. Yeah. You got Phoenix. Keep it on. You got Phoenix questions.
I want to pull this conversation back towards Phoenix for a minute. If there's any, okay, Mark. If there's any other major questions, please ask them now. Otherwise, I'm going to release my e-board to the crowd. No more questions.
Speak
Can I get a round of applause for everybody who worked on this? You guys really did me a big favor by locking in when I got sick.
Yeah, great job, guys.
Okay, feel free to mingle. You guys can go to the crowd.